data architect at the Federal Reserve Bank of New York in the technology group. And before I say anything else, I'd like to say that everything else that I say today represents my own thoughts and not those of the Federal Reserve. And I also see we have some members from our team here, which is great to see. And so what I'm talking on today has actually switched from one section to another, was competitive advantage with artificial intelligence. And what I think of, when I think about that, I think about how can a large enterprise organization get the power of AI and use it throughout to be as transformative as possible, which is different in a sense from what we've been doing in the past in data science, where we've been given a particular problem to solve or model to develop or a group of things to work on and come up with specific solutions for a specific business purpose or business user. What I would like to talk about today is how large language models can allow AI to be deployed throughout the enterprise and be truly transformative. Now, I still hope someone's coming to find my deck, but I will start without it. First thing I want to talk about is, as you all know, AI isn't new. It was conceived of in the 50s. It had its ups, it had its downs. A little over a decade ago, it had more, I guess 12 years ago, it had a renaissance with ImageNet and deep learning, and then people figured out how to embed words with vectors by looking at co-occurrences, and that transformed everything as far as NLP is concerned, starting with Word2Vec, and then BERT, and finally large language models like ChatGPT. They all work on the same principle, to start with embedding words in a vector space which represent their meaning. What's so special about ChatGPT and generative AI? And for it being used enterprise-wide, I think the point is made really in what's in bold there, which is encourages the leveraging of data assets by people who are too busy to leverage them otherwise, right? And to innovate and make evidence-based decisions. Because what everyone that practices data science knows is it's very difficult to get it out of the POC stage into production and then actually into use by the decision makers. So that's sort of the dream. And there's a great cartoon, which this is from Barbara Wixom's talk on deriving data. Actually, the book is Data is Everybody's Business. And a lot of times, this represents the cycle that we go through. I think the first one where they're putting the dirt in the pot is the ETL, right? So it's great just to have the data and collect the data. And then a lot of times, all we do is draw insights. And when I say all, that's a lot. But a lot of data science is taking this pot of data and processing it and modeling it in a way that we can develop business insights. But how far do those insights go in an organization? They may go to some researchers, some economists, to one particular business area, but it doesn't, shake the earth. It doesn't really make the kind of transformation we're trying to get. If you can relate it to taking actions, it makes a big difference. Now, there are isolated cases in AI where this has happened to huge results. Think of ad tech, for example. All the analysis goes immediately into actions and created, trillion-dollar businesses such as Google and Meta and so on, because that's where they derive their value. And that's the real goal, which is the value creation. So how do you go from data to value is really what we need to think about if we're talking about making a difference to the full enterprise and being competitive. And of course, you eventually get to eat the fruit, which is when you really realize the value. So these are the things that generative AI can do that we really couldn't do before, right? And all these things, creating content is what I think everyone first starts doing when they play with it. But having experts, we recently had a hackathon at the Fed, which we call Crunchathon, and because they don't want people to think we're hacking anything, right? And we created some conversational experts on things such as onboarding employees or economist blogs. And it was a big hit because people say, wow, you can do this? And there's a technique which is called retrieval augmented generation, which allows you basically to take documents and turn them into question and answering bots. And if you give them all the information they need in the documents you provide, they pretty much don't hallucinate and are accurate, which solves one of the big problems. So this pattern, I'm sure you'll hear all through the show. It's the easiest to implement, but it's what enables that. So now it's very different. You don't have to spend a lot of time developing an application. You can have a platform where you can have users throw in documents and click a few selections and have an expert on that domain. Now you can go further with something called fine-tuning, which now requires expertise, but soon will be, I'm sure, automated through some auto ML process where people can essentially, as business users, create fine-tuned chatbots, which if anyone said that 3 years ago, they would be laughed off the stage, but now plenty of companies planning products in that area. The other thing is the enhanced use of unstructured and inconsistent and disconnected data. So enterprises such as the Federal Reserve have lots and lots of data, but it's disconnected. It might be in a trading system, it might be in bank supervision, it might be in data security. We have a lot of areas, as you can imagine. How do they talk to each other? How do they work together to create models that can answer questions? Well, there's an idea which has been very popular over the last 2 years, which, okay, first we had the data warehouse, then data lake, a little bit better because it's more cloud-oriented, throwing everything into objects in S3. But now we have the data mesh, which takes care of, you add governance to that, you add data security, you add not allowing private data to go to places it shouldn't, and now you have a system with a data catalog where you can go in and say what's available in the enterprise. I want to solve this particular problem, but there's still another problem on top of that, which is we have found, and I'm sure others have found, that not all the data is suitable to become what they call a data product immediately for this system, because if you've ever looked at SQL tables, they're not always named the best. The columns aren't always understandable. And before you know it, you've got a data catalog of things that the data analyst thought up off the top of his head when he was naming columns and doesn't mean anything to anybody else. So we are doing research into using LLMs to help unravel that and decode that so the data catalog makes sense, which is, again, promises to unlock. But there is more. You can interpret abstract sources, so you can use images. You can embed practically anything into a vector space, and then you can search for it by saying, what's like this? It automatically clusters things. It finds things which are similar to things. It's a different way of thinking, and it makes specifying your problem much easier. Just think in terms of words. You don't have to list a lot of keywords. You can just explain one or a concept or a meaning, and anything that fits will match. And the last one is very important, but scares people, which is you can automatically perform tasks when new information comes in. So there's no reason why, once people work out the safety and security, those are the reasons why not, but once that's figured out, where you can't have a bot working off of an LLM that's been trained properly to take actions. In fact, OpenAI announced this in their last talk, can do things, can send emails, can search, can kick off any business process, potentially. And that means automation, and that means scale, and that means a huge impact on enterprises and organizations once they figure out how to do this safely. And I don't think there are large barriers to that. So just one example, everyone knows about using things like Copilot and other programs which are out there which assist in coding. Anyone that's tried it loves it, experiences an increase in productivity. I was just doing some coding the other day for something for anti-money laundering, which involved loading a lot of data into a pandas table and then filtering various things, putting rules, if so-and-so is greater than the mean, and this happens, and it's from this country, that kind of thing. It gets cumbersome when you start writing these huge group bys and filters in pandas. So I asked ChatGPT to show me an example of how to do this, and it showed it right away. And then I thought, hey, let's make this easier for me. Can I just put the rules in another data frame and have that data frame do the filter? And it produced code which ran perfectly to do that. So if I had to figure this out on my own, it might have taken me an hour, maybe less, who knows, maybe more if I forgot something. This, much faster. So, and it goes on for coding, for testing, automated testing, for maintenance, looking at logs. It promises to be a huge increase in productivity. People estimate 30 to 40%. I think it's even bigger than that. So, the next problem is, how do we do this safely? Because everyone is worried about security when you talk about enterprise AI. They're worried about their ideas leaking out. They're worried about their data leaking out. They're worried about somehow, we even had some people worry about open source models communicating with each other somehow through the internet, which doesn't happen, but we had to explain that. So there's fears in every corner of the organization about doing this on an enterprise level. They're okay if it's public data, they're okay if it's in your little corner, but once you really want to do business with it, people get scared. There are answers, right? I mean, Microsoft Azure has been, we're concerned because we're part of GovCloud, and they are FedRAMP high. So that means we can put our data in it, but we still have to have people in our security level accept that, do their testing, and go through what they do, because you can imagine it would be catastrophic if the Federal Reserve was ever hacked, since it's the backbone for all fund transfers and then some. And we have a lot of proprietary data from lots of banks, and we would lose our reputation, and everything would basically be awful. So we haven't had this happen yet, but we've got to make sure it doesn't happen. And that's why sometimes they justifiably put on the brakes for what we're doing. But the pieces are there because of Azure. On the other hand, there's, I'm sure you've all heard of Hugging Face, which is a repository of all kinds of open source models for everything. And you can scan them. We have a system called Nexus where they go in, and we're satisfied that the security is good using them. And you certainly can put in the proper safeguards so the data won't leak out. So this just has to be built, but once it's built, we can have platforms which can do these things in general. So that's where you get the real benefit. Instead of building one system for bank supervision and another system for something with markets and another system and so on, you can have a retrieval augmented generation platform internal in your organization where anyone can use it, set it up, and the security safeguards are built in so it scales. And you can do the same thing for the chatbots. So once you are safe and secure with your platforms, things can move very quickly. Okay. So, well, maybe I should get a little more minutes from when they didn't have my thing. Okay. Okay. So there's this new idea coming around, which is called the AI data mesh. And what this is this is the data mesh that I talked about before, with the addition of those two little boxes at the bottom. One says self-hosted large language model, and the other is a vector database. So what that enables you to do is take everything that you've put into your data lake, which we're now calling a data mesh, which are all your documents, all your data, everything in the enterprise, and vectorize it, which means you split it up into little chunks, and then you encode a vector from that chunk, which allows you to search for it with meaning. So it doesn't have to be an exact match. It could be show me any paragraph that talks about climate change affecting mortgages, and it will pull those sections out. Once you have that, you can automatically create a chatbot about that topic or Q&A. So essentially, by adding those two boxes to your data mesh, you can have enterprise-wide AI, which is a big deal. And a few companies are exploiting this. Databricks recently spent $1.3 billion to acquire Mosaic AI, which is one of the leading companies in generating LLMs, and this is their plan. Data IQ also has a proposal out there, and I'm sure other people will follow. I think even Oracle is interested in doing this. So it's going to be what's happening in the next year. I will skip it. This is just the same idea again and again. So I'm going to go through a very quick example. Actually, I'm going to rush through this because one of the things we did at the Fed is we implemented semantic search using vectorized bank documents, and it works very effectively. And I don't have time to go through the details, but basically it allowed us to do continuous monitoring for many different areas by setting up templates of words and rules to look for based on vectorization. And it was a big success. We don't have time, but these are all the different areas we went through. The next step for us is to generalize it with a language model, and you can have real-time ad hoc queries instead of these preset searches. We're also doing a lot of work with climate change, and for many reasons, we all know this is one of the most important problems facing mankind. And we have people, even some people in our room who are working on this. If you want to raise your hands. Where'd Mark go? Anyway, Mark, raise your hand there. And again, I'll have to rush through this. We only have a few minutes left. And finally, I wanted to show other people are actually building these models. This is something that was done by Microsoft, where they have trained something similar to a large language model. They're basically transformers. It's huge. It's gone through all kinds of weather data and can do weather prediction at different scales, both geographically and in terms of time. And this type of application of the LLM is different from everything I talked about before with language, because it's basically geospatial data, which is the most complicated data we deal with, and it works. And other people are using it for DNA sequencing and in pharma for protein analysis. So these language models are spreading beyond the domain of just natural language processing. And they're also very effective in taking documents, extracting information from them. And you can imagine the value of that. So now you can do searches and use text data as if it were tabular data. Of course, I wish I had time to go through all these because they're very important, but none of this is going to happen unless we use AI responsibly. Otherwise, it'll be a huge problem, but we know how to do that. One idea I have for this, which I can just fit in and then I will close, is people might notice that there's a problem with training language models for safety. And the problem is the more that you fine-tune them for safety, the lower they score in their general performance. So as they get safer, their IQ sort of goes down. So one thought I had about this would be to change the paradigm and not intensively fine-tune the models for safety, but then have another layer, which is a filtering layer based on another language model, whose job it is to be the cop and basically say, you can't say that. And that way you can independently control the safety, and the intelligence of the LLM doesn't have to be adversely affected. That's more reason to be cautious. And that's it. Thank you very much. Questions? Yeah, I can hear you.
My question's around how you're approaching your systems that you preserve. Are you buying, are you building it all yourself? Can you talk about your dependency on sort of external vendors versus your own team's benefit?
I can't go into details because I'm not sure what I'm allowed to say about that and what I'm not. But it's not a secret that we're using cloud services. So we're dependent on Amazon AWS. We're dependent upon Microsoft Azure. We use a variety of data science platforms. We use a variety of databases. And for constructing the data mesh, all the basic components and catalogs and so on are from outside vendors. Yeah. Yeah. Any other questions?
Can you hear me okay?
What?
Can you hear me okay?
Yes.
Yes, thank you. Great talk. Just a quick question. Have you tried benchmarking, let's say, GPT against training your own open source LLMs?
Yes, we have. But I would say that we don't have the full compute facilities to do a fair comparison, so we were using relatively smaller models in the comparison. We were using Llama 2, things like that, and a few others. And my answer to that is if you're looking for an sort of out-of-the-box, not fine-tuned solution, nothing I've seen beats ChatGPT 4. But if you're looking to solve a particular problem, like you're doing just retrieval augmented generation, and you're going to be supplying the data, then something like Llama 2 works very well.
Just, if I may, quick follow-up on that. In terms of embeddings, is OpenAI embedding better or worse than some of the tests you did with open source?
Obviously we didn't use the same embeddings, and I don't think we actually benchmarked the embeddings unless I could ask someone from our team. Mark, do you have a comment on that?
I would just suggest you take this.
Okay.
You've got Harry's information.
Okay.
Thank you so much.
Okay.
Thank you, Harry.
Thank you.